This is a video guide for Class 1 Week 1 assignment, and in this particular assignment we're going to be mapping earthquakes of global significance, and we're going to create a final regional map of those earthquakes, and we're going to run some statistics, some descriptive statistics on those particular earthquakes in that particular region. To get started, we're going to be using USGS earthquake data, and we can get this data from the Earthquake Hazards Program. Via the Earthquakes Hazards Program, we have a lot of different components of earthquakes that we can explore from a data perspective. We have significant earthquakes that we can just kind of peruse before we even get into the data, and we can see that we have a fair amount in Indonesia and Philippines that are of high consequence, very high in terms of their magnitude. There's some in Russia, one in California, one in Oklahoma. So we can get kind of a preview of these significant earthquakes different ways. We could just look at it here on the chart if we want to. But there's another location that is very helpful for mapping, and that's in their spreadsheet format. Under the spreadsheet format, it comes in a CSV, and its output attributes are organized as we can see in this list here. So we have a timestamp, we have latitude and longitude, which we'll be using. We have mag for magnitude, and we also have a place and a locational source. We have a lot of different attributes that could make a really interesting map, but what we're going to definitely be using is magnitude and also latitude and longitude. And we're going to be downloading our data from the all earthquakes for the past 30 days. And this is updated every 15 minutes, so when you do your mapping, it's going to be different. It's going to be a slightly different map than what I'm producing in the video here, obviously. And we can see in terms of a screenshot of the data, time is going to be in the first column, and then latitude and longitude. So we're going to be working with latitude and longitude and time, and then also magnitude quite a bit in this assignment. Let's just review the steps real quickly before we get too far along. So this is the Class 1 Assignment 1, creating a regional map from global earthquake data. We're going to be using the USGS data. We're going to use Google My Maps. We're going to work with latitude and longitude in CSV format. And we're also going to use a utility online called bBox Finder, which is a bounding box finder. We're going to be using the month data from USGS. And we're going to be doing 6 steps. First, we're going to acquire the data. Then we're going to upload it to Google Drive Sheets. We're going to map this data in Google My Maps. Then we're going to pick a region of high activity. We're going to determine the bounding box extent of that region. We'll filter the data based on that box. We'll derive some descriptive statistics for our region earthquakes, and we're going to create a final map of those regional earthquakes. And for our statistics, we'll just, in Google Sheets, we'll do a count. So we'll find out how many have happened, how many earthquakes have happened in the region, average and median. We'll run variance, and then also standard deviation, and get a max-min range. Okay, so that will give us a little sense of what are the earthquakes like in our region from a statistical perspective. Okay, let's go ahead and get started. And what I need to have open is Google Drive. So I'm going to have Google Sheets and Google Drive. I'm also going to be working with Google My Maps, and then of course the data itself. So the first thing I want to do is download the data. So I just go ahead and click All Earthquakes. It's going to give me a sheet called All Months. And what I'll do is I'm just going to bring all months onto the desktop here. Just move it to the desktop. And as I do that, I have 2 options now when I'm in Google Sheets. I can either upload from this location, or if I want to, I can bring the sheet into Google Drive and just link it that way. So in this case, I'm just going to use what's on my desktop. So I'll just do a right click in my drive here and say Upload Files, and I'm just going to upload all month, sitting on the desktop there. Takes a second, and then I'm going to do another right click and say Open with Google Sheets. And as I open it, we'll be able to see the universe of earthquake points within 30 days of when I downloaded. And again, it's updating every 15 minutes at USGS, so your mapping is going to be different than what we actually see. Okay, so here off to the left-hand side, we have our timestamp, which we'll be using, latitude and longitude, and then we also have the magnitude of the earthquakes. And we can see there's quite a bit of variability. So going from real small ones to, here's a 4.5. So we're going to some relatively large earthquakes to some small ones here. And we have a place name over here on the right-hand side, which gives us a distance actually from known locations, which could be really interesting for doing some mapping for points at a later date. Okay, so let's go into My Maps. So under My Maps, we need to be able to see these points. So we're just going to make a quick global map of these points. So we say create a new map. And again, we have two options. We can point it to Google Drive, or we could just point it to this all month on the desktop. I'm just going to do that for this video. So we're going to first import. So we click import, and I'm going to upload from my computer and say all month there comes up. And under the positioning of the place marks in our lab assignment, we were using city and state as a name, and then it was geocoding those points in the background to actually put them on the map. In this case, since we have latitude and longitude, which is very precise, and we could see in our sheet that the decimal point precision is pretty high, we'll just go ahead and use latitude and longitude. So if I say continue, I've got latitude and longitude picked as my place marks. We also need to pick a column title. So in this case, maybe I could pick magnitude or maybe the place. So I'm just going to click on place. You can make a choice. This is not determinant of where the points are going to be placed. And say finish. So I do that. It'll take about 30 seconds or so, depending on the file size. The actual count of earthquakes, it could take anywhere from a few seconds to even a couple minutes. I'm just going to pause the video for a moment here. Okay, that took about a little bit less than a minute. And if I zoom in here, I can kind of see some patterns. So we have lots of earthquakes on the west coast of the United States. There's also a pocket in Oklahoma, and the reason that those earthquakes are happening there is due to injection wells close to fracking activity, extraction activity in that area. That's a new phenomenon that's just recently occurred in the last decade. Also have quite a few earthquakes close to Puerto Rico and Dominican Republic. In fact, I'm going to map this area here. I'm going to set up a regional boundary that I'm going to call, maybe I'll just call it, actually let me just map these points here as my region. So I'm going to draw a bounding box around the Caribbean here and Haiti and Dominican Republic. I'm not going to include these points out here. So my region for my final map is going to be what we might call the Caribbean here. And you decide what region you want. It needs to be smaller than the actual global extent of the earthquakes. So it needs to be smaller than that, but it needs to be larger than, say, just one city. So having something like a bounding box just around Los Angeles, that's not really a region, that's more of a city. If we were to come out a little bit farther here and say the west coast of the United States, that would be considered a regional map. So the regional scale for our purposes here is between, say, a city or a state and then the actual global scale of our data set. So again, I'm going to create my bounding box in this area. And to do that, what I need to do is just figure out what my coordinate edges are. So I can do that through a utility called bbox finder. So it's bboxfinder.com. And what this utility does is show us points or circles, anything we want to draw on the map, and then it gives us a box extent for that particular feature that we create. So in this case, I have my coordinates in WGS 1984, and we can see that as we mouse over, we get different coordinate pairs as we're moving through the map. You want to make sure that you're not on the Pseudo-Mercator projection, which is 3857. That's giving us actual coordinates in a meter map projection, which is actually what Google Maps uses, but this is not what we want to have our coordinate pair come back to us, because remember, we're using latitude and longitude in our original data set. So I need to make sure that I'm clicked on to WGS 84 4326 is the code. And I want to make sure that over on the right hand side here that my coordinate format is not longitude latitude, but latitude longitude. So I click on that, and then I'm going to draw a box around where my data is located. And again, this is arbitrary. You just want to get a general regional box that's larger than your points, slightly larger. So in this case, I'm going to click on a box, and I know most of my activity is happening right here. So I'm gonna be inclusive of Cuba. I'm gonna have my regional box be this size right here. And what I get back is under box, I get a pairing of latitude, longitude coordinates that describe that box. So I'm just going to copy that and bring it into a text document. I'll just put it right here into this document. And then I need to figure out what's going to be south, north, east, and west. So I know that I have a latitude 11, which is going to be the southern edge. So I'll say 11.71 is going to be south, and 24.34 is going to be my north edge. My western edge is going to be minus 84.94. That's going to be my west. And then my east is going to be minus 59.06 for my east. And I can check just to make sure that that's correct. So if I come back over here and place my pointer along this edge, I can see that my coordinate pair under mouse is 20 minus 84. So that makes sense, minus 84 for longitude. And then over here, my longitude is going to be minus 59. My latitude up at the top is 24, and down at the bottom is about 11. So I just make sure that I have everything correct. And once I have that, I can just skip out of BBox Finder and get back into my spreadsheet. I'm going to cancel out of everything else here. And so now I have a universe of global earthquakes, and this is numbering up into the thousands of earthquakes. And so I just want to restrict it to latitude and longitude for my bounding box. And what I need to do is set up filters to actually do that process. So I need to filter on latitude, then I'm going to filter on longitude. So the way to do that is we're going to click on the column. We'll use latitude first. And under latitude, if I go back to my sheet here, I need to be between 1171 and 2434. So I put on a filter. So under filter views, I'll say filter. And there's a little green icon that shows up now to the right hand side. Click on that. And since it's a relatively big data set, it's going to take a second. And I say filter by condition. And my condition is going to be in between. So it is between. And again, it's 11.71, 2434. And I'll say, okay, I'm going to apply that filter. And then what I need to do is I find Google Sheets filtering within a filter is difficult. So what I'm going to do is create a new sheet. I'm going to add a sheet, and I'm just going to call this sheet, rename it, just the latitude. What I'm going to do is copy and paste that, that filter. So we're currently filtered. So what I'm going to do is I'm going to say edit, copy. Well, first I need to select everything. Okay, so I select everything. I just click on the upper left-hand box that's blank up here, and I say edit, copy. And I'm going to go to latitude, and I'm going to say edit, paste. Paste in that data. Let's see how many earthquakes I have. I'm just kind of scrolling through it here, being a little bit lazy. Let me go down to the bottom. So it looks like we have, for this region, 546 earthquakes, which is a lot less than 10,000 or so. Still a lot. Okay, so that's for the latitude. Now what we need to do is do a filter on longitude. So my longitude now is going to be between minus 59.06 and minus 84.94. So let's go to longitude. And we're going to put a filter on that. Filter by condition. We're going to make that condition is between and minus 59.06 and then it's going to be 84.94 and say OK. Okay, so we got that filtered. Now let's just make one more sheet and we'll export that filter. So we can call this second sheet now, we'll change the name to lat underscore long for both of them. And we'll go back to this sheet here and select everybody and say edit copy, and then go into longitude and say edit paste. Okay, so this is our final earthquake tally in our correct bounding box location, and we have 277 earthquakes. So these are the earthquakes that we're going to actually map. So we want to make sure that latitude and longitude is what we're mapping. And there's two ways you can do this. You can make sure that you're on this sheet. Another option would be to just be on the safe side, is File, export this sheet out, and do it as a comma separated value. And now this one that we just exported out, you just need to rename it. So I'm going to bring it onto my desktop here, and maybe I'll just call it regional earthquakes. Regional earthquakes. Okay, so now I know that that's my universe. That's the one I want to actually map. So but before we map this, what we want to do is, let's bring it into Google Sheets. So we're just going to say upload files, and this is my final sheet, regional earthquakes. And I'll open it up. So I got rid of everything else there. And now I have one Google Sheet of what I want to actually map and nothing else. So what we want to do now is we want to run statistics on this, and let's go through that real quick. So under the statistics, what we want to do is we want to have all these guys. So I'm just going to copy, this will be in your assignment so you could copy it also. I'm going to paste this down at the bottom, and these are our formulas. We're going to be working in the magnitude column, so we need to make sure that we change the magnitude column. So sample size is first going to be count, and let's see what column we have magnitude. So we're always going to be working in the E column here. So the count is going to be, let's get this out. Okay, I'm just selecting out the formula. Oh, I'm sorry. So the count is going to be right next to it, the cell right next to it. And so this is going to be equal. And it's not going to be A, so we want to say E2. And since I know my last column, I can just go ahead and put that in. It's 277. So it's going to be E2 to E277. Okay, so we have 276, that's correct. And then we're going to run the same guy as we did here. We'll just copy this. And for here, instead of count, it's going to be average. So we take count and replace that with average. A-V-E-R, average. So my average is 2.59. Then we're going to do median. So once again, I'll put in my count and replace that with median. There's median. Okay, so 2.54 is the median. And then we can run variance. And since we're making a regional map and all we care about is the total count of earthquakes in that region. We can use the VARP function for that. And we'll run this again and change count to VARP. Okay, 0.37 is our variance. Okay, standard deviation is great, so we can figure out what the standard deviation is of all our features. Okay, standard. It's STDE VP. Okay, standard deviation is 0.61, so these are pretty tight to each other. And then the range is going to be, let's go ahead and get this formula and make sure we're in our cell, correct cell. So it's going to be max of E2 to E277, 277, E277. Okay, so our range is 3.41. Okay, so these are all statistics that help us understand our data set. So we can see that between the minimum and maximum, there's a 3.1 range. We have about a 0.5 standard deviation, a little bit more than that. Our median average earthquake is 2.5. And the sample size, of course, is 276 earthquakes. So that just gives a statistical understanding of what's taking place in this region. So depending on your region, you may have a median that's much higher. So with these statistics, what you'll want to do is just copy this component out into your final assignment template. And when you paste it into the document, you can just paste it as unlinked, and that should work out fine. And the template kind of has the way to present it all set up, so you just kind of copy paste your values into it. Okay, so once this component's all done, we basically want to map these regional earthquakes. So what I'm going to do is I'm just going to erase all this. I'm going to have already pasted it into my assignment document, which I didn't do yet, but you will have done that. And then what we want to do is we want to actually map this sheet. We want to make sure that what we just did is out of there, out of the bottom, because it'll hang up if it sees that. It won't know what to do with those numbers. We want to make sure that our data is organized just as it is here. Okay, so we're going to be mapping these points, latitude and longitude points, for our final map. And to do that, we'll go to Untitled Map. And we're going to make a new map now. So I need to get into Google My Maps, and I don't need that regional map anymore, so I'm just going to move that to the trash. I'm sorry, the global map. I don't need the global map, so I'll move that to the trash. And now I'm going to create a new map. And this time I'm going to point it to the Google Drive. Okay, so here it is. And I just was working on the regional earthquakes. And remember, I removed those statistics. So just make sure that when you map your final regional earthquake sheet, that you're not actually mapping it with the statistics inside of it. And I'll say select. And as I do that, it's going to ask me how do you want to place the points. We're going to do latitude and longitude again. We'll title it based on the place and say finish. And instead of having all those earthquakes, we're just going to have the earthquakes that were within my bounding box. Okay, great. So there's my regional earthquakes. And before I actually finish this map, I want to do a few things. The first thing is I want to make sure that I have a base that I like. So the default base is fine. Terrain's nice. It gives us a sense of the terrain. Another one that you might want to use is dark landmass to give you a nice contrast between your points. If you want to, maybe you want to make your points a different color. So that's a little garish, maybe an orange. That looks pretty cool. So we're not going to do much with this map in terms of symbolizing it beyond just showing the points. So what I want to do here is I want to make sure that I give it a title. So for title, you want to make sure that your region is notated. So maybe my title might be Caribbean earthquakes, and then I might look at the timestamp and see what the date range is. It's maybe all of them are in August, a start and a stop date. Make sure that you put in a description of what you're actually mapping here, a short description, and then save it. So I'm just going to call this test map for right now. And for a description, I'll just say this is a regional test map. Your title and description should be accurate to what you're actually mapping. And I'll say save. And then what I want to make sure that I do is rename the layer. So again, use your actual regional name. So earthquakes in my region, whatever the region is, maybe dash the region, and say save. And under preview, we can see what it's going to look like. So we click on it, and that looks pretty good. If you don't like what it looks like, we can go back to it, and there's a couple things that we can do. We can, I believe there's a way to set default view. So say set default view. If you want to have it a little bit further out, say something like this, you could do that and set the default view. Or if you want to be real tight to the points, maybe something like this might work. That's pretty good right there for me. So I would just say set default view. Okay, and the default view has been set. So when we actually share it out, it's going to snap right to this location. And what I want to share now is I want to share this area. So here, it's currently private. I want to change that to public on the web or anyone with a link. And I'll say save it. And then this is the actual share link that you'll send out. And you can see that your map has an ID here. So it says ID equals, that's the actual map itself. And that needs to be very unique to the actual mapping that you just accomplished. Okay. So, and then we just copy C, copy paste that, or copy, Control C. Yeah, this is what it should look like. So you'll have a title to your map, then there'll be a description here, and your name. You want to make sure that this is named correctly. And also under all items, I think you can rename that also. So spend some time actually cleaning this up and making this very particular to your map. If you don't like the default view, you can change that like we just did. But this is kind of our first map. So if we click on one of these points, we can see that the place name comes up first, and then it gives us all our information here. And okay, so some of these, some of the specifics of your map you might want to talk about in your actual short write-up for the map that you're making. And all that information that I would like you to provide is in the assignment template that's linked to the assignment page for this week. So good luck with this map for our first map, and importantly, we'll be utilizing this data set that we create. So you want to make sure that you save both this map and you actually save your final regional earthquakes data sheet in Google Drive, because we'll be using that data as a component of the second week's mapping.